Exam study guide, question number 35. We're given the position of a particle. It asks in part A for an equation of velocity. Velocity is the rate at which position is changing. It is the derivative of position. So we just need to find the derivative of this equation. Derivative of cosine is negative sine. So I've already got a negative sign out there. So I've got negative 1/2 times negative sine of 2x minus 1 times the derivative of 2x minus 1. There's the chain rule. Plus the derivative of 1/2 x squared. Power rule, move the 2 out front. 1/2 times 2 is 1. Subtract 1 from the exponent gives me 1. So v of t is equal to, these should be t's here. I've got x's, sorry. There's a t, there's a t. So v of t is equal to 2 times 1/2 cancels. So we've got sine of 2t minus 1 plus t. There's our answer to part A. Part B says, find the time that the particle is moving fastest on the interval from 0 to 2. So moving fastest, we want the maximum speed. So the fastest it's moving would be its maximum speed or maximum velocity. As long as we consider if it's moving in the negative direction, the negative sign doesn't matter much there. So maximum velocity, maximums occur when the derivative is 0 or undefined. So we need to take the derivative of velocity. Derivative of sine is cosine of 2t minus 1. Chain rule says times the derivative of 2t minus 1. Derivative of t is just 1. We're going to set that equation equal to 0 and solve. To solve that, let's solve it by graphing. So go to y equals and type in your equation. We only care about the interval from 0 to 2, so let's change our window. And take a look at what the graph looks like. We're looking for when that equation is equal to 0. Looks like we only have one critical number there. We want to calculate the 0. It's somewhere in between 1 or 0 and 2. 1 and 2 would also work for your left bound and right bound. Guess just push enter again. And there's our critical value. T equals 1.547. We were trying to show that we have a maximum value there. That is the absolute max from 0 to 2. It might be at one of the endpoints as well. So we want to check the velocity at time 1.547, as well as at the endpoints of our interval, which are 0 and 2. We want to get the velocity at all three of those, and then we can compare. So I'm going to store 0 as x, and then plug 0 into velocity. Sine of 2x minus 1 plus x. So plugging in 0 gives me a speed in the negative direction of 0.841 at 1.547. Our speed is 2.413 moving to the right. And at time 2, we are still moving right, but a little bit slower, 2.141. Notice the max speed is indeed 2.413. Question wants the time, which is 1.547. Show all work in finding and testing critical values. That's what we did over here. Part C wants to know, is the particle speeding up or slowing down at t equals 1, at time 1? Speeding up and slowing down, we need the velocity at time 1, and we need the acceleration at time 1. If those things have the same sign, that means it's speeding up. If they have opposite signs, that would tell us that the particle is slowing down. So velocity, we've got an equation for velocity right there. We just need to plug 1 in. At time 1, it is moving 1.841. We don't have any units here. Acceleration at time 1. If we didn't have to do part B and we only had an equation for velocity, instead of finding the derivative, I would probably just graph this and use the dy dx function on the calculator to get the acceleration. Because we already found the derivative of velocity, which is acceleration, all we really need to do is plug 1 into our equation there. So we already stored 1 as x, don't need to do that again. Acceleration is 2 cosine of 2x minus 1 plus 1. 2.081. Velocity is positive, that means it's moving to the right. Acceleration is positive, that means that it is accelerating or getting pushed further to the right, which is going to make it speed up because they have the same sign, acceleration and velocity at time 1. Explaining your answer, I would show this, and then I would state that velocity and acceleration at t equals 1 both have the same sign. For D, find the average velocity on the interval from 0 to 2. Average rate of change, we are always going to find a slope. Note that velocity is position over time. So if I'm finding slope, I need positions, and then dividing by time is going to give me that average velocity, what I'm looking for. So we need 2 positions. We need the position at time 0 and the position at time 2. When we see velocity, we're tempted to plug 0 and 2 into velocity. But if I get 2 velocities and then find slope, velocity over time, that would give me an acceleration. So we want to get 2 positions. We can get those by plugging 0 and 2 into the position equation, which is what was given. So plugging it into negative 1/2 cosine of 2x minus 1 plus 1/2 x squared gives me negative 0.27015. Plugging in 2 into the same equation gives me 2.494996. And then find the slope between those 2 points. Anyway, here it is. I did it earlier. 2.494 minus negative 0.27015. Divide by x2 minus x1, and you should find your slope to be 1.383.